Deep in the universe, where galaxies dance like ballerinas and stars shine like diamonds, there exists a star unlike any other, a monster of a star named Betelgeuse in the Orion constellation. This star is much more than a small shining speck in the night sky. It hides behind a terrifying radiance, concealing an apocalyptic event that will revolutionize our understanding of the universe forever. As we marvel at the spectacle, we must brace ourselves for the grand finale of this celestial extravaganza and learn how Betelgeuse's death will reshape our knowledge of the universe. Betelgeuse, a red supergiant star, has captured the imagination of astronomers and the public for decades due to its strange red hue and peculiar brightness. It is one of the most familiar stars, 764 times bigger than our Sun. To put that in perspective, if Betelgeuse were to replace our Sun, its outer edge would reach beyond the orbit of Mars, even going beyond Mercury, Venus, Earth, and Mars. This larger-than-life size isn't simply an issue of scale but is a reflection of where the star is at in its life cycle. Betelgeuse has grown from a blue, hot star to the much larger, cooler red giant we see today, a dramatic transformation over the course of time. The transformation of Betelgeuse from a blue giant to a red giant demonstrates the process of nuclear fusion and stellar energy. Hydrogen atoms fused with helium in the core, producing the energy that fuels the star's brightness. But when Betelgeuse exhausted its nuclear fuel, the star's gravity caused its outer layers to expand into the red giant we know now. Unlike our Sun, a yellow-white color, Betelgeuse is reddish and warmer in light, projecting an air of mystery and allure to this massive star. Betelgeuse's tale, though, is one not of glamour but of transformation and change. Ancient cultures have documented the color changes of the star, describing a shift from yellow to blood red. The ancient observations inform us that the star has had a history of violent brightness changes. Like most variable stars, Betelgeuse's luminosity waxes and wanes in an irregular rhythm, highlighted by sudden, unexplained events. One of these took place in late 2019, when Betelgeuse's brightness plummeted dramatically. The star's luminosity dimmed at the dramatic rate of 0.1 magnitude per day to reach its minimum by February 2020. This prompted alarm among astronomers and the question: is Betelgeuse on the verge of going supernova? Or is this a temporary phase in its long life? Betelgeuse's light takes about 725 years to travel from its position in space to our Earth, creating an interesting aspect to the examination of this faraway star. Amidst the global craze and fascination with Betelgeuse's activities, astronomers must deal with the fact of what such mysterious changes would imply. Andrea Dupree, an associate professor emeritus at the Harvard-Smithsonian Center for Astrophysics, led a 3-year close-up study of Betelgeuse using the Hubble Space Telescope. The Hubble telescope, with its ability to observe ultraviolet light, allowed scientists to examine the intricacies of Betelgeuse's atmosphere. What they found were churning convection cells and material being expelled from the star's surface at speeds of up to 200,000 miles per hour. This eruption caused a massive cloud of dust that engulfed Betelgeuse, obscuring its visible light. Dupree's measurements indicated the occurrence was record-breaking in its scale, having a mass loss double that previously observed from this star in just a 3-month period. The significance of the occurrence extends well beyond Betelgeuse itself. It contradicts our current understanding of how red giants evolve and die, continuing on to supernova explosion. It was previously believed that such stars shed mass gradually before their final explosive death. However, Betelgeuse's recent massive mass ejection suggests its death could come much sooner and more unexpectedly than anticipated. Betelgeuse's rapid motion through space, at a speed of approximately 67,000 miles per hour, with respect to the surrounding interstellar medium, creates a phenomenon called bow shock. Similar to the wave that is created by the bow of a ship in motion, this shock wave is produced when Betelgeuse's outer layers interact with the interstellar gas and dust, causing a spectacular visual phenomenon. This observation not only gives an insight into the current state of Betelgeuse but also enhances our understanding of interstellar evolution and the universal cosmic processes that can lead to mass extinction. New observations continue to reveal the complexity of Betelgeuse's activity. The star's surface has cooled and become less dense following its mass expulsion, leaving it in an uncertain state. Hydrodynamic models unveil the interconnections between Betelgeuse's convective motion, mass loss, and the shift in the manner it expels material. These cooling effects give rise to new questions about the internal processes that have caused such radical changes in a star's life. Additionally, the star's rate of mass loss is far greater than other stars, signifying a complex set of internal processes that challenge the present-day stellar evolution simulations. While the astronomers are still observing Betelgeuse, they are keeping a close eye on the surrounding supernovae as well. While no one can pinpoint exactly when Betelgeuse will go supernova, there are some new observations that suggest it might happen sooner rather than later. The recent mass ejection of the star is a sign that the end is coming, and it makes the timeline for this star's death even more complicated. This evolving situation adds further complexity to our understanding of stellar life cycles and has profound implications for our knowledge of stellar evolution across the universe. Among the significant astronomical events, another fascinating occurrence has been of interest to scientists: the supernova SN 2023X. This spectacular eruption, observed in May 2023 in the Pinwheel Galaxy, is a mere 21 million light-years away, making it the closest supernova observed in recent years. The explosion provides an exciting opportunity to study the violent demise of a star and its far-reaching effects on its immediate environment. The supernova 2023X is a live cosmic laboratory that can offer us revelations that can metaphorically run parallel to Betelgeuse's own pending explosion, offering us a unique peek into stellar evolution's violent end. As Betelgeuse is approaching its supernova, the universe is offering us a rare chance to observe these dazzling cosmic phenomena. The anticipation of Betelgeuse's explosion, coupled with the recent discovery of SN 2023X, invites consideration of the universal balance of creation and destruction. The ongoing escapade of Betelgeuse serves to remind us of the dynamic, shape-shifting nature of the stars, which have for centuries enthralled and taught humanity. No matter if Betelgeuse's supernova goes off tomorrow or 10,000 years from now, its legacy will have a lasting effect on our knowledge of the universe. At the cusp of this universal breakthrough, we look forward to the next installment of the Betelgeuse saga. The mysteries of the stars continue to be the guiding force of our universal quest, and Betelgeuse is a strong reminder of the beauty and refinement of the universe. As we continue to unveil the secrets of the universe, Betelgeuse's tale invigorates our imagination, as well as enthusiasm to unravel the mysteries of the stars. As scientists uncover Betelgeuse's secrets, they're also investigating how it can shape our knowledge of the universe. The massive ejection of material in late 2019 has already prompted a reconsideration of the life cycles of red supergiants. Classical models suggested that these stars lose mass slowly and continuously before their final explosion. However, Betelgeuse's massive expulsion contradicts this idea, suggesting that the final phases of a star's life can be more explosive and less predictable than once thought. This shift in understanding not only impacts our prediction of Betelgeuse's supernova but also has a broader influence on how we model stellar evolution across the universe. The record-breaking massive ejection and accompanying dimming of Betelgeuse invite astronomers to rethink hypotheses concerning how giant stars prepare for their last hurrah. The star's dramatic hijinks have sent a wave through astrophysics as researchers ponder how similar events would unfold in other hefty stars, potentially rearranging schedules and mechanisms governing their explosive ending. The data gathered on Betelgeuse can ultimately make predictions regarding the behavior of red supergiants during their final few thousand years more accurate, constraining our models of supernovae. Additionally, the data obtained on Betelgeuse's bow shock and mass loss dynamics are significant in order to decipher the relationship between the internal processes of a star and its external manifestations. This complete image will allow astronomers to better comprehend the life cycles of other massive stars and how they affect the cosmic environment. Betelgeuse's supernova is not just a scientific event. It is of profound importance to humankind's quest to understand our place in the universe. As we prepare to witness one of the most spectacular cosmic events, we are struck by our own modest yet pertinent place in the universe's grand scheme. The prospect of Betelgeuse's impending explosion offers a unique opportunity for popular enthusiasm for science, inspiring the next generation of scientists and stargazers. As we continue to unravel the mysteries of the universe, Betelgeuse's story remains a powerful reminder of the universe's awe and intricacy, inspiring our imagination and determination to unlock the secrets of the stars.